Now let's talk about the basics of semiconductors. For starters, what's the difference between a conductor and an insulator? In a metal like copper or aluminum, a lot of atoms come together in a crystal structure. In elements like that have only one or two or three valence electrons, by which I mean the electrons in the outer shell, the bond between the outer electrons and the nucleus is relatively weak. When these atoms are grouped together in a crystal, the outer electrons leave their individual atoms and become part of a common electron cloud. And these electrons are free to move around the crystal, and if there's an electric field applied, a large electric current can flow. To understand this more fully, it really helps to think in terms of energy bands. You need to remember some principles from chemistry. Remember that the Pauli exclusion principle states that no two electrons can have the same quantum state. When many atoms are joined in a crystal, the energy states of their outer electrons can't all be the same, so they all have to shift slightly. Since there's a huge number of atoms, there's a huge number of states, each infinitesimally separated from the ones nearby. These energy states form a continuous band of energy levels that's a few electron volts wide. The electrons fill the available states, starting with the lowest energy ones until all states are occupied. They need only the lower half of the band because the spin up and spin down states are distinct. The lower energy, mostly filled states form the valence band, and the higher energy upper band is called the conduction band. The fact that the bands are continuous in energy is the key to the high conductivity of metals. For electrons to move around the crystal, they have to take on additional kinetic energy. That means they have to occupy higher energy states in the conduction band. At room temperature, there is enough energy, 1/40th of electron volt per electron, for plenty of the electrons to be in the conduction band. Now let's contrast that with what goes on in insulators. In an insulator, such as diamond or silicon dioxide, which is glass, the valence band is separated from the conduction band by a significant energy gap. The gap is about 5 electron volts in diamond, and it's 9 electron volts in silicon dioxide. The valence band is completely filled, and the conduction band is essentially empty at room temperature. 1/40th of an electron volt is not enough energy for very many of the electrons to make it up into the conduction band. And so, since no free electrons are available to flow in response to the electric field, the conductivity is essentially zero. This makes sense in terms of the chemical structure of the insulator. Diamond, for example, is the crystalline form of carbon. Carbon is in group 4 of the periodic table and has 4 outer valence electrons per atom. In the diamond crystal, each atom is covalently bonded to 4 adjacent atoms. Since each carbon atom is close to a total of 8 nearby valence electrons, 4 of its own and 4 from the neighboring atoms, this structure is very stable, and no electrons are likely to become free to move around in the crystal. So to summarize, what is the difference between a conductor and an insulator? Well, conductors have many free electrons that are free to move around the crystal. In terms of the energy bands, there's no significant energy gap between the valence and conduction bands in a metallic conductor. On the other hand, insulators have large energy gaps between their valence and conduction bands. And the outer shell electrons in insulators are tied up in the chemical bonds, and so they're not free to conduct electricity.